Okay. Yeah, I think we can get started now. Um, yeah, so just a little bit about me. I am yeah, so I am like I'm a sophomore at Basis Independent Silicon Valley. I've been doing coding for about 3 to 4 years, and um, I've been doing Yusaku like really well. And I made platinum in 8th grade, and this year I was finally named Yusaku finalist. And yeah, some other accomplishments are like JMO winner, which was this year, and Yusufu honorable mention, which was also this year. So yeah, we can get into the slideshow now. So yeah, so today we're not going to be talking about anything too complex, just some basics that you need to know before you can start solving problems. So for the next few days, we'll be talking about problem solving strategies. But for today specifically, we're only going to be talking about like setup, what Yusaku is, what the point of Yusaku is, and some of the basic language things and setting up your environment. So yeah, what is Yusaku? Yusaku is a high school programming competition meant to challenge students and eventually select the IOI and EGOI teams. So essentially, it is a computer science competition where you're given a bunch of like you're given 4 contests, and in each contest, you can have like you have 4 hours to solve 3 problems. If you do well enough, you'll advance to the next division, and once you get into platinum, if you do an entire like if your scores for an entire year are high enough, they'll select you to be one of the 30 best students to go to the training camp. And yeah, so that's basically Yusaku. Yusaku is essentially like the highest prestige competition among all high schools, uh, highest prestige high school programming competition. There are a lot of other programming competitions, but Yusaku is definitely like the highest stakes and the highest prestige competition out of all of them. So yeah, we're also going to be using Code Forces. Code Forces is one of the other biggest coding platforms that people will use. And the reason people use it is twofold. First of all, it has a great contest platform where everyone can interact with the platform. It has great API, and it allows you to put your problems. It allows you to interact with the community, and basically it allows you to interact more with the computer programming community. And um, and yeah, but another important function of code forces is that Yusaku problems, there are not very many of them. There are only problems for past contests, and past contests might not even be relevant to what's going to show up next year. So for Yusaku problems, um, generally, you don't want to just be using Yusaku problems. You want another source of practice, and code forces can satisfy that pretty well. So yeah. Um, and because we've had a lot of students sign up for this, I've created a Code Forces group for everyone to join. So let's see. Um, I'll send the link in chat, and everyone should create a Code Forces account. And so yeah, everyone should create a Code Forces account and join the Code Forces group so that you have access to all of the materials. I'll wait a few minutes for that to happen, but yeah. So this is what the thing should look like. Um, like I'm the manager, so I see a bunch of things that you guys will not see, but this is about what it should look like once you join the group. So yeah, I'll wait a few minutes for people to join, and um yeah, if you're arriving late, we just talked about Yusaku and Code Forces. So you should join the Code Forces thing. I'll send the link again. I don't think I can see people, but members. Yeah, so people are starting to join. Yeah. Oh, so the you have to be authenticated means you basically have to create a Codeforces account before you can join. So you need a Codeforces, like, so you have to first create a Codeforces account, which basically you go here, you go to register. So if you go to register, you create your handle, and you have an email and you create your password. And then after that, it'll send you a link to your email, and then you'll have an account. So yeah. Uh, uh, groups. Here. So yeah. Um, okay, I guess once like 20-ish people have joined, I'll go on to the next thing. Um, oh, so you can join by first creating an account, and then after you create an account, you click the link that I sent in chat, and then that should have like a join button next to it, and you should be able to click it, and then you would be in the group. Um, oh, yeah, yeah, yeah. The authenticated part is basically you have to create an account first in order to join. So you have to go into your account, and then once you're into the account, you have to press the link. So, um, for example, if I log out and then I go to here and then I click the link and I do this, I won't be able to join because I have to be authenticated. But once I'm into my account, I will be able to join. So yeah. Um, yeah, if there are no other issues, or if there are any other issues, you should let me know. Like, yeah, but if like because like people have gotten in, I'll just I created an account. Um, okay, so I'll deal with this later. It's not very important for the beginning of the lecture, but at the end, um, I'll help whoever um needs help on this. So um yeah. Okay, can I send the link again? Yeah. Um okay, so let's move on because there's a lot of stuff that we need to do. It might take a decent amount of time if it's because it's not that easy to understand. So yeah. Um, so yeah, so now we need to set up your coding environment. So what does this mean? Well, when you're coding in USACO, you're not like coding on an online compiler, or you're not doing any of that. You're trying to like set up your coding environment so that it's really easy to use, and it's also very efficient. You're using it very well, and you can basically you want a coding environment that helps suit you. And in order to do that, you need to do a lot of setup. So at the start, most people start using code blocks. So I'll give you a quick tutorial about how to do code blocks. So yeah, um, code blocks is like one of the most simple compilers to install, but I'm on a Mac, so I don't know if I'm gonna be helpful to any of the Windows people. But here's basically what you do. So you go to codebox.org, then you click the downloads tab, which should be, well, I can go over here, code blocks. Click the downloads tab over here. And once you click that, you can click the binary releases and then, or not binary releases, download binary releases. So yeah, and then here you have a bunch of different things. So for Mac, there's only one thing to download, but for Microsoft Windows, you will want to download the I think it's uh I think it's this one. So you download the one with setup. So you download this one, I think. Yeah, I think you download this one. And then once you download this, um, you can click through all of the buttons. Like generally the general settings are going to be correct. And then you want to, like, at the very end, it'll show you that it'll show you the directory that CodeBlocks is in. Oh, how do we find it? So we go from codeblocks.org, right? This is just codeblocks.org. And we go all the way down to downloads here. And then once we click downloads, we click download the binary release. And then now here we have to click this one. So we click this one. You can download it on either FossHub or SourceForge. It doesn't matter. Yeah, and then after you do that, you should have a bunch of windows that show up, and you can just click through them like, okay, 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 okay. And then the last one, it should have a directory. It should say the directory that all of your files will be in. So you should remember that directory. And after you copy that path, like that directory, then you go all the way down to, like, you navigate to, so now after you copy that path, you want to basically go to your advanced settings, and then there will be something called environment variables. And then you want to add that path to your environment variables. This is very complicated, but hmm. I can link you guys to a YouTube video, I guess, if you want to download it after class. Um, okay. I don't think you need to download it now, but you should try to, like, oh, I'm still on Catalina, so I didn't test Big Sur. So, oh, that might be a problem. That might be a problem. Okay. Um, I'll send a bunch of links after class is over. You guys should be able to do something, but for now, yeah, you'll need to download it for this week, but you probably won't need it as much for today specifically. So I think I'll just send like a bunch of setup information, and then if that doesn't help, then you can probably get your parents to help you. I remember when I first started, I couldn't get any of the setup to work either. So I had to get my parents to help me. So there's no shame in that. But for now, I think, okay, so if you can't set it up, you can just use cpp.sh. This should be fine. Yeah, this should be fine. So yeah. Yeah. Oh, if you have Sublime and VS Code downloaded already, you don't need to do any of this. Those are going to be much better than code blocks. But code blocks is just really easy to set up. So that's why people teach it to beginners. Yeah. Um, yeah, anyways. Okay, I guess I'll send all of this information stuff afterwards. I'll link some YouTube videos because it's a bit hard to set this up. But once you set it up, you shouldn't have to worry about it again. Yeah. So I had this thing for Mac as well, but um, yeah. Yeah. Okay. Um, I guess we can skip this part because most of you guys haven't downloaded it yet. Yeah. So I'll just talk about how to code in C++. So essentially coding in C++, you have a structure to your code, and the code starts with including packages. So first you need to include whatever packages you need. Usually people include them, like some people include them individually and some people include uh, uh, it's going to be conducted mostly in C++, but if you're in Java or whatever, then you should be fine as long as you know how to like do all of your syntax. But like the language stuff that I'm teaching will mostly be in C++. Yeah. Um, yeah. So most people will, what is the file extension for C++? Oh, the file for C++ is, wait, this thing is annoying. How do I move this? Okay, so here, the file for Mac is here. Wait, file extension for C++ in Visual Studio Code? Yeah, Visual Studio Code should definitely work. If you have that downloaded, like if you look at mine, like I have like, I use Visual Studio Code, so yeah. But okay, so if you don't have, this is getting a bit complicated. So if you don't have Sublime or VS Code, then like if you don't have any like compiler, Chromebook should be under Windows. So everything for setup for Windows should apply to a Chromebook. Um, should I use? It really doesn't matter VS Code or Sublime. Like as long as you're comfortable with using your compiler, then you should be fine. Um, for code blocks, I'll send how to set this up later, but um, yeah, if you want, you can just use this for now. Oh, okay. Anyways, um, tinker.io. What is tinker.io? What is this? Okay, I don't know what this is, but if it's a working compiler, you can also use online GDB. This also works. This is actually probably better than cpp.sh. So here you can like do everything. So like IO stream, and then and stuff like that. You can do this, but generally you want to have a compiler set up for USICO because you're gonna want to like be able to do a lot of things like code blocks, VS Code, Sublime. They can all do various things. As long as you have a working compiler for now, you should be fine. But you should try to set up a compiler. I'll send a bunch of links and stuff later. So yeah. Um, yeah. So, okay. So what you want to do is you want to go here, and so the first thing you want to do is you want to include stuff. So you can include IOStream, and that basically is input and output. And then let's say you want to deal with strings, so you do include string. So this is strings. And let's say you want to deal with, I don't know, vectors or vectors. So you do include vector. So this is vectors. And you can do a lot of things, but also if you don't want to type and you don't want to think about what you need to include, you can also do include bits slash stdc dot h. However, this doesn't always work. It works on USACO, which is why most USACO people will use this because it saves a lot of time, but it doesn't work on like a lot of different places. And in order for it to work locally, especially on Macs, you need to do a very, very special setup, which is why I'm for now going to include everything separately. So here, I'll include strings as well. And then after that, you want to, because we're going to write everything in standard, we're going to want to use this. So we don't need to do std : a bunch of times. And yeah, that's basically like the kind of like a setup of your code. And now you create a main function, which is basically the body of your code. So all of the important code goes here. And okay, so this is the global space. Which is basically like it's where every function can be there, every variable can be there, and every function can see those variables. And yeah, so you would write the most important code here, but if you ever need like auxiliary functions or anything like that, you can write it over here in the global space. So yeah. Yeah, so now we want to try to output in C++. No, you don't need to write it down yet, but yeah. So to output something in C++, you just use cout and a variable. So for example, here, let's say we wanted to output hello world. So here, cout and the string will output the string. And each of these things, each of these is going to basically be like you're outputting that next. So you're outputting hello world, and then you're outputting ENDL. And let's say you want had a variable like string x. Like if you like outputted x and then this, it would output x first, and then hello world, and then ENDL. ENDL is basically end line. Yeah, so it's here. So ENDL outputs a new line. Although I do not recommend using ENDL. ENDL is very, very slow. You should use \n instead. So \n is, it looks like this. So you should use this instead because the ENDL is very slow. Yeah. Yeah. So yeah, hello world. Okay. So now without looking at, or while looking at my code, I guess, what do you think this would output if I ran it? Does anyone know? Okay, yes, it will output hello world. So let's say I run it. Wait, what's happening? Yes. Okay. C++ 17. Okay, yeah, so you see it does output hello world. So yeah. White space is just space. Yeah. Okay, so this does output hello world. So the output function thing is correct. And you can try that on your own compilers and it should work. So yeah. Okay, now let's say you wanted to take in the user's name. So you had string name and you wanted to take in the name. And now you want to be able to output that person's, you want to be able to output that person's name in your hello world. So what do you do? Well, you can basically do this following code. So hello world name, uh, and then the exclamation point. So what do you think this code would do? If we ran it and we put our name like this, what would this do? Yeah, it will output hello world apple, right? So yeah, it's pretty neat. So this is how you do input and output in your program. So now you should try to do this. Try to write a program which will input a user's name and output the user's name 5 times. And you can just test this locally, like try to write a code that will do this. Yeah, I'll give you a couple minutes to do this and then, yeah. I mean, as long as your code works, it should be fine. It's fine. We'll learn how to do for loops later. Okay. It seems like people are done. So, yeah. Basically, the idea is that you just do this. And then this will output the name once. So you can just do this 5 times. And then, yeah, you're done. Uh, hmm. Okay. Uh, hmm. I had VS Code complain about the include part a lot, but yeah, okay, yeah, I know, but like, yeah. Um, yeah, I've had VS Code complain about the include part a lot. I feel like you can just like build the program and run it and it won't throw any errors. So it's just like being dumb, I think. Um, yeah. Oh, I don't know then. Uh, maybe for now you can try online GDB and then we'll fix it later. Yeah. So yeah, this is how you, oh, std colon colon is basically like if you don't do using namespace std, you'll have to write std in front of all of these things. Like, and you don't want to do that. Because it's in the standard namespace. So if you don't include the namespace, then you'll have to write the STD in front of everything, and you don't want to do that. So you want to include STDC plus, you want to include using namespace STD. Namespace is just, I mean, you can just include this in your code and you won't ever have to worry about the STD : things. Yeah, that's why we just include it. So, yeah. Yeah. Okay. So now that we're done with this stuff, then we can move on to the next thing, which is defining variables. So variables can be a lot of different data types. So for example, there are many standard data types like integers, longs, strings, characters, booleans, and more. And these data types correspond to different ways of storing data, each with a different purpose. And so in a lot of cases, like you'd have a data type that doesn't work because of overflow, or doesn't work because it uses too much memory, but another data type would be much better. So here we have some common information about data types, like the most useful information about data types. So integers stores an integer up to 2 to the 31 minus 1. And 2 to the 31 minus 1, this number is actually very useful to memorize. The number is 2147483647. And you'll see that number a lot in your code when you have overflow issues and whatnot. And just recognizing this number will help you a lot with debugging that. Yeah. Longs store an integer up to 2 to the 63 minus 1. Yeah, that's the 32-bit integer limit. Yeah. That number is it's universal to all languages on a 32-bit compiler, but on a 64-bit compiler, it's not universal, because on a 64-bit compiler, integers are basically the same as longs. So, yeah. A compiler is basically the thing that is running your code. So, like, yeah. Yeah, also, like, if you have questions, you should generally ask it in public, because if you're asking in private, and I'm answering the question, it might sound a bit weird, but yeah. Anyways, characters stores a character based on its ASCII value. It basically compresses each character into a different index in like 248 out of like 128. So like, for example, one character might like, for example, one character at like that's like, I don't know, in open parentheses would be a certain like number. You don't really need to memorize any of the ASCII values itself. Like, they're almost never going to be useful. And even when they are going to be useful, you can just use the character itself. So like, for example, even though knowing that 0 is 48 allows you to do like character x minus, or like, let's say x is a character, and you can do like x minus 48 or something, but you won't like ever actually need it, because instead of x minus 48, you could just do x minus the 0 character. So yeah, it's not very useful to memorize ASCII values, but it is useful to know a little bit about them. So you should know that 0 is 48. Like, you should like not like know, but like if you see, like, if you're outputting 0 or something and then it's giving 48, you should kind of like recognize that. You should also know that uppercase characters are lower than lowercase characters. And but like, besides that, you don't really need to know much more. I think you also should know that lowercase a, I think, is 97. I think. I don't even remember this, but yeah. Yeah, it's not really that useful. Strings are just an array of characters. So its memory, of course, depends on the size of the string. So yeah, in a string, you can access the ith character by doing like str of I, accesses the ith character. But yeah, it's basically an array of characters. And a Boolean stores a true or false value. Oh yeah. Uh, because I didn't send it in chat. But, so I'll just send it then. Okay. Yeah, and a Boolean stores either true or false value. And you'll notice that I use bytes and not bits. And because like it's much easier to represent everything in bytes. So 1 byte is 8 bits. Oh, I think character should be 1. I think I think I typoed that. But these memory values should be pretty easy to remember. The only tricky one is a Boolean. And a Boolean, it should take one.
I have fur.
Oh, it should theoretically only take 1 bit of memory, but based on the way that like your code is structured, based on the way that the compiler is structured, it actually takes 1 byte of memory. So that is useful to consider because storing Booleans is very, very inefficient. Yeah. There are also other data types like shorts and other things like, but those are never going to be useful. So yeah. So how do you define a variable? Well, you define a variable, it's pretty intuitive. Oh, why should you care about how much memory it is? You should care about how much memory it takes because let's say that you have like a problem and you know you're going to send an array of size 1000 by 1000 of integers. How many megabytes will that take? If you don't know how many bytes an integer is, you won't know how many megabytes that'll take. So it's a really easy calculation of 4 megabytes if you know the integer is 4 bytes. But if you don't know, then you would have to do like, oh, an integer is 32 bits, 32 bits is 4 bytes, yeah, and then you have to do all of that. But if you know this, then you can do that calculation really, really quickly. So yeah. How to define a variable? The way you define a variable is you basically do data type to variable name. So for example, here you have int variable equals to 0. So that would initialize your variable called var to 0. If it's declared globally, so let's go back to this code. Let's say you declare a variable globally, or you declare a variable globally, then this is automatically initialized to 0. But if you declare a variable here, this variable will have an unknown value. It's uninitialized, which means depending on the compiler that you use, it'll have a different value, which is very, very bad. That's called undefined behavior, and that causes your program to do a lot of really, really bad things. So you should always make sure that your variables are initialized, even if you're never going to use that initialized value. Like say this is you do this. Uh, Even then, that's probably still going to be better than not initializing it because that'll cause undefined behavior. Yeah, Java does also default to 0. I believe every single language defaults to 0 besides Python, and in Python, you can't declare a variable. So yeah. No, you should not always define variables in a global space because um, you sometimes want variables within your functions and stuff. You just want to make sure that all of your variables are initialized. Yeah. Okay. So basic operations on these things. this should be fairly initialized means it has an initial value. Like uh okay. You should send your messages to everyone so everyone can see what you're asking. Um yeah, but uh uh basically an initialized like okay, I can send the question. Okay, that was the question. So basically initialized means it has an initial value. If it doesn't have an initial value, like if you don't like declare equals to whatever and it's in a local function, then what happens is it won't have a value. And you can assign it to a value, but it won't have a value until it's assigned to a value. And when you try to like access that and try to do like addition or whatever with that value, then you'll get something known as undefined behavior. And undefined behavior can cause your program to do really, really odd and really bad things. So you generally want to make sure that all of your variables are initialized. So yeah, um, basic operations are basically like these are like the most common ways to utilize integers or whatever. You can set the value of a to b. So for example, if int a equals 2 and b equals 1, then if you do a equals b, then you output a. What do you think this will return? Okay, yeah, 1 is correct. This will output 1. Um, yeah, and then you can do a lot of things. So you can do a plus b. So you can do a plus b. And so what does this return? Oh, C out. Oh, C out is basically, yeah, yeah, it will return 3. C out is basically output. Um, yeah. Also, like generally you should ask your questions to everyone so that when I answer them, it's not very like awkward. So yeah. Um, and then okay, and then a minus b, a times b, a divided by b, and a mod b, they're all very similar. Um, yeah, and then a plus equals b is essentially so a plus equals to b is the same thing, is equivalent to a equals a plus b. So these two statements are completely equivalent, but generally plus equals is easier to write, and people use plus equals a lot. So yeah, um, yeah, and then you also have a minus equals b, a times equals b, a divided by equals b, and a mod equals b, and they're all basically the same thing. They're basically a equals to a operation b. Um, yeah. If statements. So if statements take in booleans and allows you to like conditionally go into pieces of code. So you can either go into a piece of code or you don't go into a piece of code. So this is basically what allows you to do everything within this is what basically allows a computer to be in a computer, not a calculator. It allows you to go into certain segments of code and do them, but also it allows you to not go into certain segments of code. So it's very, very useful. And this is the syntax. Yeah. So let's say we had a equals to 5 and b equals 5. Okay, wait, actually, no, let's do the next slide first. So implicit conversions. So in programming languages, there are implicit conversions from various data types to Booleans. And this is very, very useful, especially when you're just like passing in variables into your if statements. You don't want to just like, you don't want to have to like do like a bunch of like things before you can even pass into the if statement. You want to just be able to put in the if statement and then it'll do its thing. So the way this works is for integers, if the value is non-zero, then it returns true. Otherwise, it returns false. So let's say you had if a b minus or b equals 10. What would the value of b be? What would the value of b be? If this was your code. So remember, if it is non-zero, then it is true. So it will execute that and it will make b equals to 10. So b will be 10 afterwards. And for long longs, it's the same. So if it's non-zero, it is true. Otherwise, it is false. So yeah. Boolean operations. So let's say you wanted to compare like two things. So like if a is less than b, or if a is greater than b, or whatever. And you can do that by doing these. So if a is less than b, that is represented by a is less than b. If a is greater than b, that is represented by a is greater than b. And if a is equal to b, this one is a double, like you have to have two equal signs equals b. And the reason you have to have two equal signs is if you remember a equals b, what does that mean? That means you want to set a to b. That's not what you're trying to do here. You're trying to return true if a is equal to b. So you have to put two equal signs to distinguish between them. And there are other things you can do like Boolean arithmetic or Boolean algebra, I guess, like this kind of thing. So like, for example, let's say we had this thing again, and then we wanted to say if a is less than or equal to b, or b, or okay, so or b is greater than a. And b is equal to 5, b equals 10. CL B. What would this program output? Yes, it will output 10 because this will essentially take the OR of this and this. And although this evaluates to false because B is not greater than A, this will evaluate to true. So as long as this evaluates to true, this if statement will go in and then B will do this. What if we added this? Would it still be 10? Oh, yeah, okay, yeah. It will still be 10 because the else statement is basically if this is not true, then it'll go here. But it is true, so it won't go there. So yeah. Yeah. That's basically Boolean operations. Loops. So you guys wanted to do this earlier, but in order to execute a specific set of code multiple times, we use things called loops. So there are three types of loops: for loops, while loops, and do while loops. Generally, most people only use for and while loops because do while loops are they're very like they're not better than while loops or for loops, and they're often going to be much like they're going to be like very niche and not very useful. So generally people only use for and while loops. um yeah so the syntax for these for and while loops: so for loops are basically for a, b, c. So a, b, and c are all individual statements. So for example, if we have a for loop here, let's say we have for A++, B++, C++. So what does this do? Well, okay, so what does this do? Well, in the first iteration, it'll go through to, okay, so it'll go through to the first thing. So it'll go through to A. So after it goes through to A, it'll increment A. Now A will be 2. And then it'll go into the loop. And once it's into the loop, it will never do the statement here. It will never do the statement here again. So this statement only happens at the very start of the for loop. Now it'll do these two statements. So after you're done executing the random code, it'll go to this statement. Once it goes to this statement, it basically will go to this statement afterwards. So after you're done with executing this statement, it'll go to this statement. And now here, it will check if the middle statement is true. If it's true, then it'll keep going. But if it's false, it'll immediately go out of the loop and it'll go over here. So for example, this is probably a bad example, but, oh, wait. Okay, this is probably a bad example, but let's say you had something like this. What would we get? Okay, what would we get if we did this? And okay, I should specify what A++ and B minus minus are. So A++ is basically A plus equals 1. And what will A++ return? A++ will return A at the end. So it'll return the value of A. So what will this program output? Does anyone know? Oh yeah, this style of for loop is very different from Python. But if you learn Java first, this is essentially the exact same thing. So yeah. Yeah, Python is very, very different from all the other languages. So if you learned Python, it's going to be very hard to like change languages. But if you learn like C++ or Java, it'll be much easier. Okay, let's do a simpler example. Okay. For int I equals 0, I is less than 2, I plus plus. What will this do? What will this do? This is the format that you'll see most often, but it's not the only way to use it for loop. So, yeah. Yeah, so basically it'll output 0 and then it'll output 1 and then it'll end. Yeah, so, yeah, we can do this. Yeah, it'll output 0, 1. Okay, yeah. Yeah, it seems most people understand this. Okay. Oh, well, okay. So the idea is that think about it. No, don't think about it whether it stops at 2 or it stops at 1 or whatever. Think about it this way. It executes this first. So first it declares I equals 0. Then it goes into the loop. See out I, which is 0. So that's the 0 here. Now it'll go back into the loop. First it'll do this. So now I is 1. Then it'll do this. this is true. So it'll go back into the loop and output one. After after it outputs one, it'll go back here. It'll make this two, and then it'll check whether I is less than two. If I is less than two, then it keeps going. But because I is equal to two, it'll stop, and then it'll just end the program. The plus plus basically means plus equals to one. Um, yeah, okay. Let's move on, I guess. Oh, so at the very start, it'll execute the leftmost thing. Oh, this is C++. Yeah. So it'll execute this first thing. And then after it executes this, it'll check whether this is true. Then it'll do this. Then it'll do this. And then after that, it'll check whether this is true. And then it'll keep going. Oh, so it executes the rightmost thing before it checks whether it's true. So it'll always do the rightmost thing before it checks if the middle is true. Uh Python is really weird. Um if you can start with Python and you can go pretty far with Python in competitive programming, but at a certain point Python will just be unusable and then you'll have to use another language. And then it'll be really, really weird. Yeah. 17, yeah, 17 is just a version. All of them should be the same. Yeah. Okay. Anyways, let's keep going. So, yeah, while loops, the syntax is much easier. So it's basically, it goes through the while loop, it checks whether A is true. If A is true, then it does it, and then it checks A if A is true again. So while A is true, do this, and once A is not true, it stops doing it. So, uh, I wouldn't say that's true. I'd say Python, you could go up to gold potentially. Like you could definitely go up to gold very easily with Python. Um, it'll be a bit hard to get into plat with Python, but it's been done before. For Java, you can go all the way to camp with it, but like it's definitely not optimal to use Java. Um, yeah. Um, yeah. So for while loops, let's say you had a loop like while true. If you had something like this would run indefinitely because it'll say, oh, it's true, and then it'll execute this, and then, oh, it's true, it'll execute this, and then it'll go on indefinitely. So while loops, you need to make sure that it doesn't go on indefinitely. Um, yeah. And then, yeah. So let's do a practice problem. Um, yeah, given a list of n numbers, find the sum of all of them. This should be pretty easy. Uh, for and while loops aren't actually that different. Like for example, if you did for loops are a lot more complicated in the sense of like what you have to do, but in a for loop, the first thing is what you do before, the middle thing is what you check. So this is what you check, and the last thing is what you do every time. So uh wait. Only happens once. Only or check whether it is true every single time. And this is um, basically happens every time. No, it goes left, right, or left, middle at the very start. But then after the very start is over, it's right, middle, and then right, middle, right, middle. Yeah. Yeah, and you get the list of numbers from STDN. Um, and yeah, the recording will I believe be posted to yeah, I believe the recording will be posted to YouTube. So yeah. Okay, so does everyone know like does everyone is everyone able to do this like locally at least? Like do you have like code that works? Oh, okay. Well, I'll give a couple more minutes to think about this. So we're trying to solve this problem. You're given a list of n numbers and you want to find the sum of all of them. So you would basically input n, so like in n, cn, and then do something to input all n numbers and find the sum, and then see out sum at the end. Okay, does everyone know how to do this? Or should I explain? Um, okay. Okay. So I'll try to explain how to do this. Um, Essentially, you want to declare a variable sum, which will be the total answer, right? And then you want to also be able to input all n numbers. So how do we write a for loop or a while loop that is able to input all of the numbers. Well, we can do like the format that I described earlier. So for I equals 0, I is less than n, I plus plus. So how many times will this for loop iterate? Well, it'll go from 0 to 1 to 2 to all the way up to n minus 1. But when it gets to n, it will break out of the loop. So how many is that? 0 to n minus 1 is n times. So this will do whatever's inside n times. So now we can basically input a variable. So let's say x, cn, x. So now we've inputted all n. What's happening? Okay, so now we've inputted all n numbers, and now we just need to find the sum. And we have the number over here. So if we do sum plus equals x, then if you think about it, like sum, x will be added to sum every single time. Because sum starts at 0, and you add x to the sum every time, sum will eventually return the total sum of all n numbers. So this is basically how you do it. Yeah. And if you wanted to do it with a while loop, you could do I equals 0 here, and then you could put I plus plus here, and then you could make this a while, and then just do this. I could declare x outside of the for loop, but it's just, yeah, you can do it both ways. Yeah. Yeah. So the answer would be something like this. So yeah, this would be like a code to solve that. Yeah. So now let's learn about arrays. So in many instances, you might want to store more than just one variable. You might want to store like a variable amount of variables. So the way you do that is to declare an array. So to declare an array, you do, so this is the data type, and then you first declare the data type of the array, then you declare the name of the array, and then you declare the size of the array. So for example, you would have int array or ARR of 1000. That will declare an array of size 1000 that has 1000 integers inside the array. And this is initialized similarly to a variable. So if you initialize it globally, then or if you put your array globally, then it'll initialize every single element within the array to 0. But if you initialize it locally, then it won't initialize anything. So all of the values in the array will be undefined. When you access them, it'll give you undefined behavior. And that means that you would need to go through to every single element to initialize it. So generally, for the sake of competitive programming, not for the sake of the real world, for the sake of competitive programming, most people declare all of their arrays globally. So yeah. How do you make an array? Well, okay, I'll illustrate it over here. So let's say you wanted to make an array. So it's int array of 1000. So now what this does is it initializes an array of size 1000. It initializes an array of size 1000, and all of them are integers. And because I defined it globally, all of these would be set to 0. Yeah, so this is how you initialize an array. the way you access an element from the array. So let's say the array is like, uh, the array has like 1, 2, 3, 4, 5, 6, 7. So let's say array of 0 equals to 0, array of 1 equals to 1. And what this does is it basically accesses the ith element of the array and it sets that to 1, or it sets that to 0, or sets that to 1, something like that. Yeah, Java is very complicated because in Java, there aren't really arrays. There are only array lists and vectors. And um, the difference is very subtle, but also very important. So it's very like when you're starting to learn Java, it's very confusing because it's like C++ does not have array lists. C++ just has arrays. Yeah. Um, Array lists are basically like linked lists. Vectors are like a dynamic sized array. Um, the difference is very subtle. I won't go into the difference now, but eventually, if you like start learning more about what Java and C++ do, you'll learn the difference between a linked list and a vector. Yeah. So Java doesn't have arrays. C++ does, but Java has linked lists too. Um, okay. Anyways, this Java versus C++ discussion is besides the point. We're trying to learn about how to use arrays. So array initialization. Arrays, I already touched on this, but arrays that are initialized globally are initialized to 0. But if you initialize it locally, like within a function, none of the variables, like none of the values within the array will be initialized. And so that means that you need to manually initialize them with a loop or by like accessing that or whatever. And array indexing is also very confusing. So array indexing starts from 0. That means that if you declare an array of size 10, its largest element would be array of 9. Uh, Array is basically just a list of numbers. Um, yeah, you don't need to like know all of this like random stuff about linked lists and stuff yet. You just need to know that arrays are just a list of numbers, and you can basically um, use this list as like it's very yeah, it's very good. So you can declare like basically if you declare an array of size 10, it'll have indices from 0 to 9. It will not have a 10. So if you ever access array of 10, like if you declare an array of size 10 and you ever access array of 10, that will give you out of bounds errors. And that's like very, very, very bad. So you'll have a lot of problems with out of bounds errors if you like don't know the indexing. In addition, if you ever access like -1 or like anything really, really large, that'll also give you out of bounds errors. So you should make sure that um, you should make sure that you avoid out of bounds errors by like knowing the indexing and also making like doing corner cases for like n equals 0 because that might go out of bounds. So yeah. Um, um, The unit for array size is just an integer. So um, yeah, it's just okay. Do we all understand arrays and array indexing and array out of bounds stuff? No? Okay. So wait, what do you not understand about the arrays? So arrays are oh, so basically you do it like you can initialize an array and then you can access an array by doing array of I, which is the index. And then you can access it that way and treat this as a variable. And then if you like initialize it locally, then like if you do this locally, then you need to deal with initialization issues and stuff like that. So you generally want to declare it globally. And because it goes from 0 to size -1 for the indices, you should just like keep track of that for array out of bounds. Yeah. Um, you can't directly print an array. So if you have like an array like int array 1000 and you want to do like cout array, that won't work. Instead, you'll have to use a for loop. So you have to go from, you have to like do this. You have to do this instead. Um, yeah, this is how you would print an array basically. Oh yeah, multi-dimensional arrays. So in order to do a multi-dimensional array, you can just do this. So this will be the first dimension, and this will be the second dimension, and it works the same way. And in order to access it, you just do this. So it's very, very simple. If you want to do even more, like even bigger arrays, like you could do something like this. You can do like something like this. And this would give you like a bunch of dimensions in your array. Um, yeah. What do you mean by is that even visual? Okay. Um, yeah. So you can do a lot of things with arrays. So yeah. What would oh like if you had to access uh like 5D array? A multi-dimensional array, it basically can store things like sometimes it's better, it's like more efficient to use a multi-dimensional array than just a normal array because sometimes you have 5 parameters and you want to just like put them in. And in order to access this, it's just like you do the same thing. You just put 5 of them here. Generally, you won't have anything beyond 3 dimensions. Like beyond 3 dimensions is going to be pretty, um, yeah, pretty unusual. Usually it's going to be 3 or less dimensions. So yeah. Anyways, okay, let's move on to our challenge problems. So This is the challenge problem for loops. So you're given n, and you want to write the following diamond of not width n, size n. And an important note about this is that note that the size, or you want to note that the size is n 2 times n minus 1. So this is the diamond for n equals 5. You notice that this width is 9 and this height is also 9. So you want to create this diamond. That's your first challenge problem. And your second challenge problem is arrays. So you're given an n by n grid of numbers. How many pairs of adjacent points are there such that their numbers are the same? Yes. In fact, the grading server is in the group that you guys just joined. So yeah, it's the first contest. Oh, um, the link is here. Yeah, these are your challenge problems. So yeah. You don't have to register. Just click enter and then click the problem, and then you should be able to like read it and then submit code for it. Yeah, it shouldn't be that bad. Oh, wait. And something interesting is that if you go here, you can see everyone else who solved the problems as well. So yeah, I guess these two problems will be your homework, but you'll have the rest of the time to work on it. And yeah, now help. Well, okay. So if you already know Java or Python and you want to code it in that language, you can use that language. But uh, if you are using the language that I was teaching today, you want to use C++. Yeah. And you submit by going to the code forces. So you can read the problem by looking at this, and then you can read it over here. And oh wait, wait. Oh no, this is buggy. Oh no, I think I had the wrong code here. Oh well. Okay, and then you can submit code over here. Yeah. Your code is only allowed to run for 1 second. So yeah, you shouldn't worry about the time complexity. Yeah. Um yeah. Okay. Uh yeah, I'm gonna fix the diamond problem statement because I think I had a bug. I think uh like I think I submitted the wrong code. I mean, I like made the wrong code the main thing. So I'll change that really quickly. And then also help whoever needs help. So if you needed help with the Code Forces group things, you can ask me for help now. Okay. So um I guess the meeting is gonna end very soon. So um yeah, just try your best to do the problems. If you can't do the problems, then someone will explain them tomorrow at the beginning. So yeah, um, I guess bye and see you guys tomorrow.